everyone. So before we start our lesson today, let's start with a quick recall. So in order to understand the antiderivatives of exponential function, we should learn first the formulas of differentiation. So for the number one, it's a derivative of e raised to x. So as we all know, the e stands for the Euler's number. So the first question is, what is the value of the Euler's number? The choices will be flashed on the screen and you can pause the video if you want to answer. So yes, the answer or the value of the Euler's number is 2.718. So back to the exponential function. So to answer the derivative of this exponential function, ang gagawin natin is the product of the exponential function e raised to x and the natural log, which is ln e. So since ln e is equals to 1, the answer or the derivative of this exponential function will be its original function, which is e raised to x. So for the next formula, it is the derivative of a raised to x. Considering na ang a natin here is constant and it is greater than 0, what do you think is the derivative of this exponential function? So, correct. Our derivative here is the product of the exponential function a raised to x and the natural log or ln a. For the third question, I will give an example and everyone will give their answer on what it is derivative. So our example here is y equals 2x. So you can pause the video if you want to answer and look at the choices below. So yes, the answer for this is 2 raised to x, not natural log or times the natural log of 2. And this is our final answer. And that is the end of our recall today. Now, let's move on to the theorems of antiderivatives of exponential function.
So in theorem number 1, we have the integral of e raised to x dx. So to get it, we'll think of a function that if we differentiate it, we will get the derivative of e raised to x. So from our recap, we talk about that the derivative of e raised to x is itself. So in antiderivative, it also applies here. So to start it, we have the e raised to x adding the arbitrary constant since we will be getting the general antiderivative of the function. So applying this theorem, we have this example. So our example is the integral of 2e raised to x dx. Ang una nating step dito ay ilalabas natin itong constant sa unahan. So, 2 times the integral of e raised to x dx. And, applying our theorem, ang gagawin natin is i-multiply natin itong 2 sa e raised to x. So, ang mangyayari dyan ay 2e raised to x and adding the arbitrary constant plus c. So, ayan, so simple ng ating first theorem. So, our another example is the integral of negative 5e raised to x dx. So, katulad ng kanina, ilalabas muna natin itong constant. So, negative 5 times the integral of e raised to x dx. So, ang mangyayari dyan ay i-multiply lang natin to. So, negative 5e raised to x and adding the arbitrary constant or yung c. So, ayan na agad ang ating final answer. For theorem number 2, we have the formula, the integral of a raised to x dx is equals to a raised to x over L and a, or natural log of a plus the arbitrary constant c. So, this formula tells us kung anong dapat natin i-differentiate to get a raised to x. So, the log a tells us na ang kukunin lang natin is yung coefficient, which is i-disregard natin yung exponent niya. So, we need to build any coefficient that will counteract the natural log a. So, minsan kasi sinusulat siya as the reciprocal of log, which is ganito, L and A. Pero, in this theorem, we're going to use this formula as na A should be greater than 0 and also A should not be equal to 1. So, for our first example, we have the integral of 3 raised to x dx. So, ang simple lang gagawin natin dito, we're just going to apply this formula by just substituting the value of a. So, the value of a here is 3. So, equals 3x, I raised to x, is equal, all over ln 3 plus c. So, ganito lang ating final answer. We're just going to substitute the value of a raised to x. Second example, we have the integral of 2 raised to x plus 1 dx. So, paano to? Meron tayong x plus 1. So, basically, ang gagawin muna natin dyan is to expand. Ganito. So, the integral of 2 raised to x times 2 raised to 1 dx. So, here, we have our bases. So, di ba kapag exponential function siya, kapag same ang base niya, simply we're just going to copy. So, ang gagawin natin sa exponent is i-add lang natin siya. So, ang gagawin natin is, since ito ay constant, so 2 raised to 1 is 2 times the integral of 2 raised to, ito, x dx. So, after natin makuha to, i-apply natin yung formula na ito. So, simply, we're going to get the, here, ibababa natin yung constant. Then, itong value ng a natin, which is 2 raised to x over natural log of 2 plus c. So, ito na ang ating final answer. So, what if you're given a problem in which kailangan ang dalawang theorems, or we simply say combining the theorems of exponential function? So, we have here an example. The integral of e raised to x plus 2 raised to x dx. So, our first step here is we separate the two terms. So, the integral of e raised to x dx plus the integral of 2 raised to x dx. So, if we combine this, we will have, so applying the two formulas, we will have e raised to x plus 2x, 2 raised to x, natural log of 2 plus c. So, this is our final answer.
Ano yan?